So chapter 5, lesson 6, adding linear expressions. Some of you might be wondering what a linear expression is. What is that? And I'm going to show you what that is in just a second. Okay. First thing I want us to do though is I want us to remember or practice how to simplify again, because this is kind of part of today. If I had this 4b plus 2 minus 2b plus 9, what would I do to start simplifying this, Connor? Okay, so like b's and b's, right? And then maybe your constants. Remember what a constant is? It's anything without a variable. So then I'm going to say take 4b minus 2b, and that's 2b. 2 plus 9 is 11, positive 11. So this is what my answer would be. This right here is a linear expression. Okay? Linear expressions are basically answers to what we were doing yesterday. And what we're going to be doing today is it's going to be like two expressions that we simplified, and then we're going to add the answers together. Is what's going to happen. So we're going to always have something about two of these in our problems today, and I'll give you more examples in just a second. Let's do one more, just to make sure we're all good. Let's do this one. Somebody else tell me what to do for this. Somebody else. Merrick. Okay, and? Okay. And if I put those together, what do I get? 2 C's and 1 C? Do you know? Negative 2 would be like 2 cats, 1 dog. I'm 1 cat, right? So I have negative 1C. And then I'm going to put these two things together. What's 7 minus 3? 4 plus 4 is my answer to that one. Everybody remember how this goes today? Okay. So what I'm going to have you do is I'm going to write the definition for linear expression first. And then I'm going to talk about some of these things. Okay, that sound all right? So definition first, and then I'll talk about what's on the bottom of this page. And I think I'm going to add in here, and it can have an addition or subtraction sign in it. So I'm going to, it doesn't always have to, but it can have an addition or subtraction sign in it. Sorry if you already wrote that, but that to me just didn't sound right. So I had to look back at the book. So you might be wondering what exactly a linear expression looks like. Well, remember what we talked about? It's like an answer to what we've done. These would be considered linear expressions. Okay. This could also be considered a linear expression. You might say, well, why? It doesn't have an addition or subtraction sign in it, but what could I do? Could I do this? Could I do that? So technically that's also considered a linear expression. Okay. Over here, these are not. Why do you think these two are not? Do you need that, Merrick, yet? Which one do you need? That? Is that all right? Why do you think these are not linear expressions over here? Jasmine. Top one has more than one variable. Yep. And why do you think that bottom one is not? It's got that exponent. Okay, so anything that has an exponent, not a linear expression. Okay, anything that has more than one variable, not a linear expression. Basically, everything else is though then. Okay, these are considered examples. Maybe you want to just put this as an example. So, you don't have to put all of them. Maybe just write. It's up to you how you want to put in here what is and what's not. Okay. So for today, I'm going to show you two ways to do this. I'm going to show you two ways to get an answer, and then you choose which way you like the best. Fair enough? Okay. Choose which way you like the best. Luckily, we're not subtracting. We're going to do all adding today. So don't have to worry about keep changing anything. We're all adding. Ready, Merrick? Okay. All right, so what's this going to look like? Oops. This is what it's going to look like today. So remember how I said it's basically two things that were simplified. Now we're going to add those answers together is what we're doing. So this is what your problems are going to look like. 2x plus 3 plus x plus 4. So this would be considered a linear expression here, and this would be considered a linear expression here. I don't know why I put them so high up there. Move it down a little bit. I'm not that tall. So the first thing I'm going to do, I see that x, I'm going to put a 1 in front of it. Same rules apply. The only variable, I'm going to put a 1 in front. Okay, so let me show you the two ways to do this. One way you can do it is, remember when you were young and you would put them on, line them up like top and bottom? Okay, that's one thing you can do here. You can do 2x plus 3 plus 1x plus 4. Okay, here's the deal. You have to line up, though, the things that you can combine, right? So, like, I could put x over here because I can't combine those two things. I have to line up what I can put together. So then what happens is I basically draw a line in here, okay? Because I'm going to treat this as two different addition problems, okay? So what's positive 3 plus positive 4? Positive 7. 2 plus 1. 3x. Here's my answer. That's it. Okay? That is pretty easy. That's one way you can do it. Now remember, if you're going to split it up, make it so the lines in front of these signs, because remember those signs have to help you tell if they're positive or negative then, because it's like treating it like two different problems. Now another way you can do it is you can just say, okay, well, what's 1 plus 2? 3x. What's positive 3 plus positive 4? Positive 7. So either way, but I'm going to be honest with you, this way is what we're going to want to use for subtracting. So if you want to use the same way for both, then choose this way, because this is going to be the easier way for subtracting, okay? Just to let you know. So if you want to choose the same way for both, then I would choose this one right here. This one. Any questions so far? None? Okay, let's try another one. 2x minus 1 plus x minus 5. So do you want me to show you both ways, or do you want to do the one where it's up on top of each other? Which one would you rather have? Okay, line them up. Okay. So then I would do 2x minus 1 plus 1x minus 5. Then I would split them up, because like I said, we're going to treat them like two different problems here. So I would do this, remember? So this would be a negative 1 plus a negative 5 then. Negative 1 plus negative 5 would be negative 6. So negative 6 on this side, 2 plus 1, 3x. There's your answer, 3x minus 6. See, not bad, is it? This isn't hard, and it helps that you dealt with it before. It helps that you learned to simplify, so you know how you can put them together, and you know you need to keep the signs together. Not tricky. Not tricky. Want to try one by yourself? Okay. Try this by yourself. Know the answer? No, they're going to give it to you already. No, they're going to just what I'm doing for you. Nice work. Nice work, you guys. So what'd you get, Kaylee? Correct. Nice work. 5x plus 8. Nice job. I'm going to show you another thing they're going to do. I'm going to add another one for you. What if they asked you to add 3? What would you do? You could put 3 on top of each other. Or what could you do? You could, yeah. That would also be easy. Because I feel like if you got to add 3 together and you're dealing with a negative in there, it's kind of hard to do that. So I feel like the easiest way to do this would be to do the first 2, get the answer, and then add that last one to that answer. That way you only have to deal with the negative ones, and otherwise I feel like throwing another, it's be kind of hard to do in your head. What's that? Sure. Sure. So let's see, 2x minus 3 plus negative 1x plus 4. And then because I know today they might give you 3 to put together. So I just want to make sure that we talked about that. Remember you're adding them, so 2 plus a negative 1 is just a 1. Remember you're adding them, not multiplying. Did you get it? Confident? Yeah. Okay. How we doing, Jacob? Not good. How come? This is good, except for this should be a positive 1. That's a positive 1, right? It's negative 3 plus positive 1, so that should be a positive 1. Otherwise, everything's good here, except for that should also be a positive 1. 2 plus a negative 1, positive 1. You don't need to use that today because we're not subtracting. That's tomorrow. Yep. Good. I think that's the right answer. Let me check and see if I can do it. Check and make sure. So this would have been 1x. That's a plus, right? Plus. So it'd be plus 1. And then this is my answer. Then I'm going to add that third one. 3 plus, like this? Is that right? So biggest thing, signs today, I think. Careful with your signs. Okay, I have one more thing I want to show you before I let you work on your homework. Because I don't think this is too bad today, right? Give you a lot of time to work. Ready? Okay. All right. So I want to show you a story problem because they're going to have a story problem for you. And if I were you, I'd write down an example. I'd write this example in your notebook because they're going to have something exactly like this in your homework for you. They're going to give you a shape, and then they're going to give you the sides of the shape. And they want you to find the perimeter. What's perimeter mean? What's that? Yep, all the way around it. So if I want to know the full perimeter of this, what will I do with these? Add them together, right? So I have 3x minus 3, 2x plus 9, 5x plus 0. And I'm going to add all those together to find my perimeter. So I'll let you draw if you need to draw and get everything down that you need to get down. And then go ahead and add those sides together. And then I'm going to add one more element here for you. Okay? So first let's do what we were talking about. Bless you. So finding the perimeter means you find everything all the way around. Where'd you get the 9? 2x plus, I see. Hey, look at this. Negative 3 plus 0 would be negative 3. You gotta change on your other one then. Very good. Yep. Negative 3 plus 9. Yep. Good job. Okay, so adding these all together, I bet you got this. 10x plus 6. Okay? Now what if I said x equals 3? What could I do now, Jasmine? What would I do with my x? Could I put it in for here then? Now they're telling me what x is. Can I solve it now? Sure. So what's 10 times 3 plus 6? Could I have taken x and put it in for all of these? Do you think so? Do you think I would have got the same answer? Yes, I would have. So if I put 3 in for here, let's see. So 3 times 3 is 9, minus 3 is 6, 2 times 3 is 9, no, 2 times 3 is 6, plus 9, 15, 5 times 3 is 15. If I add all these together, guess what I get? 36. Hmm? What, putting them all in? I know, it's easier to actually add these up first and then put your x in for here. They're going to do that for you today. They're going to give you a problem exactly like this. And they're going to say, if x is 7, figure out what the perimeter is around the whole thing. So it's up to you which you think is easier. You can either do them individually, fine. You can add them together and then put x in. It's up to what you want to do. Okay? Any questions on this today? Getting the hang of it? Biggest thing, signs. Watch your signs when you add them together. Okay. Ready? Get your book out.